I'm gonna make a video going over this test because I will not have time to answer every single question in class. So I'm gonna just go ahead and do the whole test for you guys. So this is implicit differentiation. Y is not in terms of x. So derivative of 3x squared, that's gonna be 6x. This is a product rule. So it's gonna be the first function, which is 2x, derivative of the second, which is dy dx, plus the second, and then derivative of the first. All right, derivative of y squared is going to be 2y dy dx, and then derivative of a constant is 0. I'm going to take these two terms and move them over. So if this is my equal sign, I'm going to subtract over the 6x, and I'm going to subtract over the 2y. So those are both gone. And then from the two terms that are left, I'm going to factor out dy dx. And what's left will be 2x plus 2y. That part is going to get divided over. And when you go to look for your answer, they're going to have simplified this. First, they're going to divide everything by 2. So it's going to be a 3x and just a 1y and a 1x and a 1y. And they're also going to factor this negative, and it'll just be sitting out front. So let's see if we can find the one that matches that. We're going to have the negative out front. It'll be 3x plus 1y, and then just x plus y. So B for that one. All right, an equation. You need a point and a slope. They give you the point, you just need to find the slope. You don't actually need to write the whole equation, first of all, because these are all your choices. And secondly, the slope is different for all of them. So once we get our slope, we're going to know which one is the answer. So basically, I'm just going to do this derivative and plug in 1 for x and negative 3 for y. So 2x, this is another product rule. The first thing is negative 3x. So first derivative of the second plus the second derivative of the first. There's a bunch of ways you could think through that. But as long as both terms end up negative, then you're good because you have to subtract the entire product rule. You could pretend it's positive, do the product rule, and then just make both terms negative. I treated negative 3x like the first function, however your brain does it best. All right, plugging in 1 for x, and that's going to give us this. And then negative 3 for y, negatives are going to cancel, so positive 9. So 2 plus 9 would be 11. We would subtract over the 11, divide by negative 3. So I got positive 11 thirds, and that's going to be E. I don't need to go any further because, again, all the slopes were different. All right, here is particle motion. Well, it's particle motion, but it's really a related rate. They're saying a particle is moving according to this equation. We have a 0.34, so x is 3, y is 4. We have dx dt, we want dy dt. So we're going to do our derivative with respect to time. Kind of like that ladder problem. Do you remember the ladder falling down the wall? It's really kind of like that, just instead of being given a story about the ladder, they just called it x and y. The particle moves on a circle, but it's very similar. All right, so we're going to plug in 3 for x. Dx dt is 6. Y is 4. Dy dt is what we're looking for. Goodness, what is that? 12 times 3 is 36. This would be 8 dy dt. You would subtract over the 36, divide by 8. Those are both going to reduce by 4. So that will be negative 9 halves. So D for that one. All right, this is arguably the hardest question on the test. A tube is being stretched. The reason it's difficult is you have volume and you have surface area that you have to contend with. They give you all this information. I'm going to kind of skip that for a second. I know I need to find the derivatives of both of these. So let's do dv dt first. All right, oh, that looks like a W, sorry. dv dt. All right, product rule. So first, pi r squared, derivative of the second, dh dt, plus the second times derivative of the first is going to be 2 pi r dr dt. All right, and I'm going to do the same thing for surface area. Again, it's a product rule. So first derivative of the second plus second, and then derivative of the first. When I did this question on the study guide, it's these exact same derivatives. I can't change that because it's sort of by definition. This is the volume, that's the surface area, and then these are their derivatives. So we're going to do a substitution with this like second part. You see how it's like almost the exact same, except this one has an extra little r in there. So that's like the part that's similar enough that we're going to be able to substitute one into the other. But I actually forget how it goes. Let me go and read through this. All right, height is increasing at the rate of 2 millimeters per second. So dh dt is 2. At the instant when the radius is 6 millimeters, volume is increasing. So we have dv dt, and increasing means it's positive, 96 pi. That's good that there's a pi in there because we'll get some cancellation with pi. That might be all that we get. Okay, so let's start here with dv dt, since that's the one that I have some information about. And let's see, r is 6. So 6 squared is 36. That's going to be 36. And then dh dt is 2. So 36 times 2 is 72 pi plus, and then r is 6. So 6 times 2 is 12. So I have 12 h pi dr dt. I don't think I have dr dt. All right, let's go with it because I know I'm going to substitute this somehow. So if I subtract this over, if I minus 72 pi, oh goodness, what is that going to be? 24 pi equals 12 h pi dr dt. So let's see how I can do some substitution. ds dt is what we're trying to say something about surface area is increasing or decreasing here. I'm pretty sure it's going to be increasing since everything else is positive. I can probably get rid of those two. Let's see, 2 pi, r is 6, so 6 times 2 is 12, dh dt is 2, so 24 pi plus, and then let's see what I can substitute in. Let me see what I have that matches up here. dr dt, pi, I have h. Kind of want this to be a 2, so I could substitute the whole thing in. If I divide both sides of this by 6, I can take this 4 pi and substitute it in for 2h pi dr dt. So this entire portion I'm going to replace with 4 pi. So 28 pi is what I got, and that is A. Again, arguably the hardest one on there. But I did not want to leave it out. You're going to come across stuff like that on your AP exam. And what I would suggest is skipping them, to be real honest with you, but you need to be able to read through and go, hey, this is going to take a really long time. Maybe I should skip this one and come back to it. All right, mean means average. This is going to be average rate of change, which is just slope, equals instantaneous rate of change, which is derivative. So I'm going to get a slope on my interval 0 to 2. So I want to point 0 something and 2 something. If you plug in 0, you're just going to get 0. If you plug in 2, that's going to be 8 minus 8, which is 0. You can go ahead and do the slope if you want. It would look like this, but that's just going to be 0. So our slope is 0. We want to set our derivative equal to 0. So actually, this is Rolle's theorem, and we're finding critical points is what's going on here. So I'm going to factor out an x. It'll be 3x minus 4. You get x equals 0, and you get x equals 4/3. This one is an end point on your interval, so you get rid of it and just 4/3. So D for that one. Rectangular area is being used one side, and then fencing on the other two. So one side is going to be a wall. You just have fencing on the other 3. I gave you a trick for this one. To get your x and your y, you're going to divide this in half, and then you're going to divide it in half again. To get your volume, you multiply those together. A lot of times it helps if you put the 9/1. Fractions tend to throw people off, but if you multiply those together, you just multiply the numerators, multiply the denominators, 81 halves, and they even put the squared on everything for area. So E for that one. All right, for this, we are looking for a place where first derivative is positive. This is your sticky note. All right, first derivative is positive. That means your function should be increasing. So I know it's not this section. And second derivative is negative, means concave down. So this section is concave up, like a smiley face. So I don't want that. This one is concave down, or like an upside down parabola, like it's bent downwards. So from B to C is the part that we want, which is Roman numeral 2, which means our answer is B. That one wasn't too bad for a Roman numeral question. Sometimes those can be, a lot. All right, G is twice differentiable, which means there's no problems. It means you can get all your derivatives. First derivative is positive. That means increasing. Second derivative is positive, means concave up. So that means it's increasing, and it's increasing at a faster rate each time. It's increasing at an increasing rate. So we have the point 412, and then we have the point 518. They want to know what 6 could be. So you're just continuing the pattern. To get from 12 to 18, you add 6. Here you have to add more than 6. So just 6 is not enough. We are increasing at an increasing rate. So if you take 18 plus 6, you're going to get 24. It has to be more than that. So it has to be E for that one. Oops. All right, this is not the graph of f. It is the graph of f prime. That's actually good because the derivative is the one that tells you all your information. We want to look for relative extrema, which just means maximums and minimums. These are your critical points. Here we have a change from below to above. That's negative to positive, which means minimum. This one here is also negative to positive, which means minimum. This one is a change above to below or positive to negative, which means maximum. So we have 2 relative minimums and 1 relative maximum, which is A for that one. All right, function G is given by that function. What is the absolute minimum? This is your candidate's test. So we're going to get our derivative, set it equal to 0 to get our critical points. Oops. I wish I had some white out. Oh, I do. I don't know why I wrote 60. Sometimes your hand gets ahead of your brain. Also, I'm writing with pen, which I shouldn't be doing. All right, I'm going to divide everything by 6. And then I'm going to factor it. This is all just algebra here. The only step that we did that was calculus was the derivative. All right, I want a positive 1 in the middle. So I want positive 2 times 1, so positive 2 minus 1. Making my table. My candidates are my endpoints, so negative 2 and 1, and then my critical points. This one gives me negative 1. This one gives me positive 1/2. All of that was not too bad. I found a derivative. I did some algebra. I got my critical points. To be honest, this is the part that I tend to get annoyed with because you have to plug all of these back into this original function, and it's non-calculator. This is my pep talk. They are going to do this to you on the AP exam. Just do your best to get through it. We're going to plug these in one at a time and just see what we get. Negative 2 cubed would be negative 8 times 4 would be negative 32. I'm just going to do a margin problem here. Negative 2 squared would be 4 times 3 is 12. Negative 2 times negative 6 would be positive 12 and then plus 1. So I know 12 and 12 is 24 minus 32. So it would be negative 8. Sorry, I just wanted to double check in my head. Would be negative 8 plus 1 would be negative 7. All right. Actually, I can go ahead and stop there. And I know that's my answer because it says what is the absolute minimum? And none of these other numbers are smaller than that. So I actually know it's going to have to be A. So I'm going to actually go ahead and stop there. I'm going to use my test taking skills. Now, if you plug in the rest of these, you'll get other numbers, but none of them is going to be smaller than negative 7. And none of my other choices are smaller than negative 7. So actually, I can avoid doing the rest of that. So great. All right, point of inflection, we're going to get our second derivative and set it equal to 0. All right, so first derivative, 15x to the 4th plus 40x to the 3rd. Keep on going, we get 60x to the 3rd plus 120x squared. I'm going to set it equal to 0. I'm going to factor out 60x squared. That would leave me with x plus 2. This factor is not going to give an inflection point. You do end up with x equals 0, but the squared keeps it positive. And an inflection point, you need to have a change. Critical points are critical points whether there's a change or not, but inflection points only count if there's a change. So this factor with squared, again, squared means positive all the time. There's not going to be a change. This one gives us x equals -2, and that is going to have a change. So that's going to give us our inflection point. So B for number 11. All right, there's going to be way more information in this table than we actually need. They love to do that to you, give you way more stuff than you actually need to look at. Also, this is a Roman numeral question, so let's be careful. Twice differentiable just means there's no issues. We have f prime, f double prime. Which of the following statements are true? F has neither a relative maximum or minimum at 2. Well, let's see. At 2, we have a critical point, so we could have a maximum or minimum. And our second derivative is negative. Don't get hung up on the fact that it's -1.9. Just negative will do. It could be -1,000,000. Negative means concave down. And so that means that that critical point is a relative maximum. And I always just draw a picture. Concave down, facing downwards, like a downwards parabola or like a frowny face. So that one's false. It says neither, but we would have a relative maximum there. That's what Roman numeral 2 says. Relative maximum at x equals 2. So that one's true. And then relative maximum at x equals 8. So at x equals 8, we have a critical point, but our second derivative is positive, which means concave up, and that means that's going to give us a relative minimum. So that one is false. So again, we want 2 only, which is B. All right, let f be a function continuous on this interval. We have the point 2, 10. I just like writing them as ordered pairs instead of in this function notation. And then 4, 20. What is guaranteed by intermediate values theorem? Well, the function's continuous, which is the only condition we need. It just means you're going to have something in between each of these, in between 10 and 20. You get all the values in between 10 and 20 on that interval. So you get 11, 12, 13, 14. You get 10 and a half, 11 and 3/4. You get all the numbers in between because the function is continuous. So it's actually going to be A. 13 is in between 10 and 20. So you have an output value of 13 at least one time on this open interval. If you were wondering why it's not any of the others, f of 3 equals 15. Well, 15 is in between these, but can I guarantee it's the point 3, 15? No, I mean, 15 will be on there, but maybe it's 3.5, 15. I can't guarantee it's that specific at that exact point. Attains a maximum on the open interval 2 to 4. That's true, but it's not intermediate value theorem. That's your extreme value theorem. So while that's true, it's not what the problem's asking for. Derivative equals 5. I think if you slope these, you will get 5. So that is also, oh, actually, that's not true, though. That would be mean value theorem, but your function needs to be continuous and differentiable. So first of all, it's the wrong theorem, and secondly, it doesn't meet all the conditions. And then this one's talking about the first derivative being positive. That means the function needs to be increasing all of the time. Well, I don't know. Maybe it increases, but maybe it goes down and then comes back up. I don't know. I have no other information than the starting point and the ending point. If you have a starting point and an ending point, yeah, it might just connect like this, but it also, might do that. You have no idea, so you can't guarantee that. So again, the answer was A for that one. All right, graph of f prime, which again, you want to have f prime. It's the one that tells you all the information. We want where f is decreasing. That is where your derivative is negative. So that's this section and this section. So 0 to 2, 4 to 6. That's a sticky note problem. Wait, why am I not seeing that one? This is decreasing, or your first derivative is 0 to 2, 4 to 6. E, sorry. I just didn't see that on there. My brain did something weird. I was like, why is the choice I'm saying not there? No, it's right there. E. 0 to 2 and 4 to 6. Now we're getting into the free response. This one, we're given the graph of g, the derivative of the function f. So f prime is g. Oh, whoops, white out. F prime is g. And we'll talk about this a lot more when we gear up for the AP exam. Oftentimes when that's the case, they want you to link these together. So you should probably write this somewhere on your paper. But then when you go to do your justifications, you can either say F prime or you can say G. I tend to say F prime because the derivative is the one that gives you all the information. So I write F prime, but you could also say G, it won't matter. Annoyingly, this question printed on the other side. All right, so on this interval, -5 to 6, on what open intervals, we're going to use parentheses, which you should always do anyway, We want f to be increasing and concave up. Humor me for a second while I write out our sticky note. Increasing positive, decreasing negative, and then increasing positive, decreasing negative. And then I can add in my concavity. So I have concave up, concave down. Oh, this reminds me, and if I forget to say this in class, I'm going to say it here on the recording if anyone is listening. A bunch of you left your sticky note behind. Do you think you're done with this and you're not going to need it anymore? Like, don't ask me for another sticky note. I would say like 5 people just left their sticky note on their desk. You still need it. This information is not going away. All right. Anyway, word to the wise. Get yourself another sticky note because you're going to need it. We want where f is increasing, that's right here, and concave up, that's right here. So that's where the graph we are looking at, because we have f prime. Again, remember, they're asking you questions about a graph that you are not looking at. We want positive, which means above sea level, and increasing. So let's go write our sentence. Above sea level, so positive, and increasing is going to be this section. So 0 to 1, union 4 to 6. Some of you wrote 4 to infinity, and I accepted it. They will not. The interval was from -5 to 6. They will just flat out mark it wrong. I took it because I knew what you guys meant, but they will not. Right? So that was worth a point. And then it's because f prime is positive and increasing there. So it was a point for the explanation. If you wrote it, there are no pronouns, all right? You have to cite your source, who you're talking about. It has to be f prime. If you say it or the graph, they will not give it to you. And some of you got flowery in your language. Keep it simple. F prime is positive and increasing there. Just go with exactly what it says on the sticky note. Don't get more fancy than that, right? Inflection points on the graph of f, which again is not the one you're looking at. Inflection points is a change in concavity, up to down or down to up. So we're looking for a change in the graph we're looking at, increasing to decreasing or decreasing to increasing. The constant parts don't count. So this is not an inflection point. This is not an inflection point. This is not an inflection point. The only one is at x equals 4. All right. We have a change in our derivative from decreasing to increasing. So we're going to say, for this one, I'll put it in here. X equals 4. It was a point for saying that, because f prime changes from decreasing to increasing there. And it was a point for that explanation. So keep it simple. Don't get more complicated. Just do it exactly like I showed you. This one is difficult, mostly because of this negative sign in it. Really, that negative sign is the hardest part of it. All right, concavity is a second derivative. So we're going to get a first derivative, and then we're going to get a second derivative, and then we're going to make a number line, and we're going to say our answer. This one's a whole big lot of algebra. All right, product rule. First thing, and then derivative of the second. So e is itself, but you have to chain on the derivative of negative x, which is -1. So I'm just sticking the negative in front there. Plus the second thing times derivative of the first. I'm going to go ahead and factor this before I go on to the second derivative because it will make my life a little bit easier. I can factor out a 2e to the -x. Or actually, will that make it easier? Probably not. Maybe I'll just leave it alone. Yeah, I don't know. Now I'm debating. This problem's a mess with the negative sign. Welcome to the inside of my mind. This is where I'm like, should I do that? Well, you know what? Let's just see what happens. All right. This is going to be another product rule. We have the first thing and then derivative of the second. So again, e is itself. Oh, but you know what? When we chain on the negative, they're going to cancel. So it'll be positive. So I don't need that gap in there. All right. So first derivative of the second plus the second, and then derivative of the first. So this whole thing was another product rule. And then here, if you want to think of this as just 2e to the -x, it's not a product rule. You don't have to treat 2 as its own function. It's just a coefficient. So it's going to be just itself, but you have to chain on the derivative of -x, which is going to make the thing negative. So -2e to the -x. All right, can I combine any like terms here? Let's see, this will be 2x e to the -x. We have -2e to the -x and -2e to the -x. That'll be -4 e to the negative x. I want to set this equal to 0. I can factor out a 2 and an e to the negative x. That will leave us with x minus 2. E is exponential. If you want a visual of this, it's going to have a horizontal asymptote at 0. And because of that negative, it's just going to swoop downwards instead of upwards. But the point is, this will never equal 0. So that is not going to do anything for us. Also, it's above sea level all the time. So if you made a number line out of it, it would be plus, 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 plus the whole way across. All right. So I really just need to make a number line for my x minus 2. It's going to change at 2 and be negative and turn positive. I totally forget what the question was asking at this point. All right, concave down. That's going to be this negative section. So negative infinity to 2 because second derivative, oh, you know what? Did it even ask for an explanation? Is negative there. It might not even have asked for one. You know what? It doesn't even ask for an explanation. So you probably shouldn't even put that. This is your answer. All right, it was a point for the first derivative. It was a point for the second derivative, and it was a point for the answer. So 3 points for that one. That one was really hard because of the negative sign, mostly, in my opinion. All right, and then we've got a full free response question. Need a separate piece of paper for this. All right, so let's see. We have time. We have thousands of gallons. Oh, there's this. I was like, what is the story? All right, a gasoline storage tank is being filled up. All our numbers are, it says it's being filled. You'd think all the numbers would be going up. Anyway, amount of gasoline in the storage tank is given by the twice differentiable function g. We have times from 0 to 10. And we are told that the second derivative is positive. That means concave up. So that is going to come up at some point in this problem. I don't know when, but we are going to need that. So letter A, use the data in the table to estimate, we won't find it exactly, rate of change. That means slope at time 3. Time 3 is going to be in between here. So I want my points for 1. Don't be too proud to write them out. And 5. If you mess up a slope, you are going to be upset. All right. Do not simplify this, but it does say indicate units of measure. It is thousands of gallons per hour. I had someone on the test, and if you did this, I'm not picking on you. I've just never had anyone do this before, so I want to make sure I mention it. Wrote like K gallons per hour. Don't do that on the AP exam. I took it, but they will not. All right, that was worth 1. If all you did was this and didn't have the units, they will not give it to you, and there aren't any half points. You either get it or you don't. All right, times 0 to 10. Is there a time when g of t is increasing at a rate of 0.2, which is 2/10? I think it's easier to think of it as a fraction, gallons per hour. We're going to do a really similar thing to what we just did right here. We want 0, which is 22, and then we want 10, which is 24. I just grabbed that from up here. 0, 22, 10, 24. So if you do your slope, and this one I actually do want to simplify down. Let me fold this paper over so that you can see it, so I don't have to keep on sliding the paper up and down. All right, there we go. So that's going to give us 2/10, which is 0.2. So it was a point for doing that slope. And then you have to bring up your mean value theorem. So since that's our slope, we know that there will be a time when g of t is increasing, or you could even say g prime. I would just repeat exactly what they say in the problem, though. But you have to mention that the function is differentiable and continuous. So I think they said twice differentiable. We're going to say since g of t is differentiable, it is also continuous. And again, I'll take diff and con. I'm not 100% sure on those on the AP exam, so probably write out the full word when you're actually taking your exam, but I'll accept those. And now I'm going to just repeat the prompt. I know it's annoying to write this whole thing, but you'll get the points. There is a time when g of t, what is it, is increasing at 0.2, lost my place, thousands of gallons per hour by mean value theorem. Or, and I guess I should say on 0 to 10. You're just repeating the prompt. So is a point for your explanation. So 2 points for that one. If you lose your mind and you can't write out that little sentence there, at least do the slope. You'll get a point for that. Let me fold this over so that I'm not having to keep on moving the paper around. All right, it is known that the derivative at 5 is 0.5. Locally linear approximation, it means write a line. Linear means line. You need a point and you need a slope. So I need my 0.5 something. Let me grab that from the table. It's 19.5. Slope comes from derivative, and they just told me that the derivative at 5 is 0.5. So here's my equation. It should technically be t instead of x and g instead of y, but they will accept this. And then we're going to do our approximation at time 7. So I am going to plug in 7 for x, and I need to add this 19.5 over. You get a point for that approximation. I wish I could say it was a point for the writing the equation and then a point for plugging in, but they were stingy. They only gave you 1 for that approximation. I had someone plug in and not move over the 19.5. I'm not sure if they'll give that to you or not. You have to get y by itself. They will still give it to you if you don't put the squiggly equal sign. You can put an equal sign. They'll still give you that, but you have to get y by itself. All right. Under or overestimate, it comes back to what they were talking about with the concavity. If you have a graph that is concave up, if you draw in a tangent line, your tangent line is below, like, do you see how this tangent line is below the graph? So we're going to say underestimate because G double prime, what did they say, is greater than 0. So G of t is concave up. So there's a point for saying that. You can't just say G prime double prime is positive. They said that in the question. You have to connect the fact that the second derivative is positive with the concavity. You have to connect those two concepts together. All right, and then last one, we are given the rate is this. We want to find on 0 to 10, so that's our interval, when the rate is an absolute maximum. This is your candidate's test. So we're going to get our critical points. This is a quotient rule. So denominator derivative of the numerator minus the numerator derivative of the denominator over the denominator squared. I had some people leave off writing the denominator because we're not going to use it. You lose the point for the quotient rule. I get that if you take this and multiply it over, 0 times anything is going to give you 0. You still have to write it to finish your quotient rule. All right, so that's going to go away. Again, if I multiply it over, 0 times anything is 0. We're going to distribute the 100 here. This would be minus 200t squared. That gives you negative 100t squared. When you combine like terms, you will subtract over the 400, divide over the negative 100. You get plus and minus 2, but our interval is 0 to 10. Also, you can't have negative times, so just 2. So we're going to plug into r of t, which is the original function. We want our endpoints and our critical point. And let's see, where is that original function? It's hard to have 2 pieces of paper up here. All right, so if I plug 0 into this, I get 0 over 4, which is just 0. If I plug in 2, I'm going to get 200 over, what is that? 4 plus 4 is 8. If I try and simplify that down, that'll be 100 over 4, which is 25. And if I plug in 10, I'm going to get 1,000 over 104. I don't know exactly what that is, but I know 25 is bigger than that. So let's see. I think it was maximum. So our absolute maximum is 25 at time 2. You don't have to put because anything. The table is your justification. It was a point for the quotient rule. It was a point for setting it equal to 0. So if you even did this first step, you got 2 out of the 4 points. It was a point for finding time 2, and then it was a point for doing the table and writing the answer. So like this part together was worth 1 point. Free response always add up to 9. So that one was 4. Let's see. Part C was 2, so that's 6. Part B was 2, so that's 8. And then part A was 1, so that's 9. So again, they always add up to 9.